Hello, everyone, and welcome to the eccenca talk series. Thank you very much for tuning in. Today, we have a very exciting guest with us, and I've been really excited to have him join us. His name is René Pietzsch, a colleague of mine. We've been working together for over 10 years. René, thank you very much. He's become a very dear friend, and honestly, he's on my speed dial. So every time I have a crazy idea, I try to ground it in a conversation with him. So He's had me calling him on weekends. I'm sorry about that, by the way, calling him on vacations. But I've for the eccenca talk series, I've been really looking to bring him in because as he's my sounding board, I wanted you to have the opportunity to also meet him and learn from him because his insights are amazing. And yeah, I'm excited to have you. Thank you for coming, René.
Thank you for the kind intro. I'm happy to be here.
René, obviously, as your role as head of product, you are very much confronted with the task of making sure that our customers are successful in their AI projects. And of course, when we get there or out on the street, there's a lot of discussion about the success rate of AI projects. And there's an MIT study out last summer, and it kind of correlates with what we see when we go out in the market, that 95% of AI projects fail. And that's, of course, a staggering number. And we wanted to shed some light today on why we think they fail as compared to the 5% that work, and what do the 5% that work, do different, or what have they understood that the 95% haven't grasped yet. And I think you've brought us a bit of an example of where we see the problem or how we tackle the problem so that all of our customers are very successful in their AI projects. And thus, we are a little bit surprised to those statistics. But hey, René, why don't you talk our audience a little bit through where you see the problem and how it should be tackled?
Exactly. So let's get into this example. So I brought a very basic one from the logistics. Let's assume we have some overseas container arriving in a container ship in Hamburg, and we need to get that down to our warehouse in Cologne. So quite easy task, right? Ship loaded with 40 tons of cargo in two 20-foot overseas containers, arriving in Hamburg today, maybe, and let's say tomorrow in the afternoon, that cargo needs to be in Cologne. Easy peasy task. And everyone that looks into AI automation nowadays would assume that, okay, that kind of dispatcher's task is something that we can easily hand over to that LLM model. And yes, why not? Let's try. And in order to help you to understand why still we see these 95% of projects trying something like that failing, we built that little graph here to illustrate the inherent complexity of even this very basic and even simplified problem that we came here, right? So we have a batch of cargo and sitting on a container ship. We need to load that on a truck, maybe on two. Already first decision that need to be taken, right? Do we have enough drivers available? Do we have the trucks available? Can they carry the capacity? Can they carry the one or the two containers that we have, right? Can they actually arrive in time at the harbor? Do they get the harbor slot? Are the cranes free to have the container loaded onto the truck, right? So what does that mean to book a slot in Hamburg Harbor? Does it come with a lead time? Who needs to do that? Who can do that? But then even if we say we decided for one or two trucks, let's say we decided, we understood that harbor slot ticket booking needs some lead time, so we put that in place. Do we also know that we have all the accreditation and security checks in place for the drivers to actually enter the port of Hamburg with the truck itself? So you see, even if in this oversimplified problem, there are lots of decisions that need to be taken and that need to consider important background knowledge and the very level of detail. And let's say in this picture, we have 10 objects here. Around 2 decisions need to be taken for each of these objects, right, to come to the full picture and to the full decision. And let's assume we use a classical LLM approach where decisions can be taken and answers are made with let's say around 85% of accuracy and correctness. Doesn't sound quite correct if you multiply this with the number of decisions that you need to take in order to close this issue here. Let's say we go down into document RAG, where people report to push accuracy to 91, 95%, something like that, even not close, right? So it's just, let's say we go to GraphRAG, modeling the contents of the documents in an even fine-grained structure that pushes the envelope maybe to 95%. Again, if you multiply this with 20 decisions that you need to take, you're not even quite close to 100% dependability. So that's kind of illustrates the problem a little better, maybe.
Yeah, so what you're saying, you have a lot of moving parts, and we need to, when we're thinking about building an AI project, we need to really think of, take a mindset of a product quality management approach, where we look at all the components that make up the product, and we need to make sure that at the end, the product has to have 100% quality. We need to kind of figure out a way to make sure that all the components of the decisions have 100% quality. Otherwise, the lacking quality of the different components add up, and they add up in a way that you don't have 95 plus 95 plus 95% precision to end up at 95% of the composite product, but you're actually getting to the point where you're going to 85 or 80% quality probability in your final product, meaning that the more components you have, the higher the probability that you're going to fail. And that's why what you're saying is the GPT models are failing at larger industrial use cases, right? I mean, is that basically the story that you're bringing, right?
That's my conclusion for the 95% that we've seen and read about in the MIT study, right? And that's obviously also in that contextualizes good with the projects and the use cases that we actually support. To just shed some light on these other industries. So we support pharma customers to help them understand and overcome their research silo problem, right? So really understanding what researches have been conducted, contextualizing this with their very own work, because each of the unnecessary kind of double conducted research costs them hundreds of thousands of euros specifically per case, right? Wasted. We look at other customers in aviation, for instance, where we support cybersecurity scenarios where security checks need to be taken in near real time. With human in the loop, in this case, it doesn't cut the case. You're looking at days and months of work where you need to have near real-time security grading in place. We're supporting customers in the telco industry where really big savings can be unlocked. Having a dependable, reliable digital twin of their machinery, of their network infrastructure. And that is actually what we build. And to my understanding and my conclusion here really is that you need to build, and I would also like to draw this metaphor here, you need to build a rock-solid foundation in order to drive deterministic, dependable decisions. Right. And
yeah. So,
looking back at this picture, right? So you really need to dissect a problem in order to understand all the ingredients that you need to have available at every point where decisions need to be made.
So this is a very German. This is a very German skill, actually, right? So we are Germans. We are engineers. We know how to build big machines that composed of millions of parts and still deliver dependable results every day, every hour, for millions of things. And what you're saying is, just to kind of compare, on the one hand side, you have the GPT, the elegance, the interaction, but you have the probabilistic nature of the technology that also defines its elegance. They've found the agent neuron, and they've been able to take the probabilistic nature out of the LLMs to make sure it produces 100% quality. But it also took out all the elegance, because it ended up being just an SQL query, basically, right? So it doesn't work that way. But on the other hand, you need the scaffolding in quality and governance, around data, around context, around knowledge. Those elements are totally critical to building big, reliable machines. And that's an engineering task that you cannot hand off to an AI, right? And so if you're looking at the 5% that are successful, I think those are the ones that understand that if you've got a hammer, not everything is a nail, right? So if you have an LLM is a nice technology, and you could have an electronic screwdriver or something, right? But you wouldn't try to drive a nail into the wall with it.
No.
So I think it's really about choosing the right technology for the right task. And this call is not about bashing GPT technology. We were talking about why it's not working, right? And we want to help, right? And why
I would even say the absolute opposite is the case, right? So let again just focus a bit on this example. The semantic scaffolding, as you called it, and I think it's a really great term here, is very important and can superbly be supported and driven by the LLMs, right? But so first of all, if you dissect that problem again, is a harbor slot booking, is this just a string artifact that a document reg dissection finds in several of these documents, or is this really a key decision point? Same goes with harbor security accreditation for the drivers in order to allow them to actually enter the port of Hamburg, right? Is this just an artifact that is like a footer in a letter just written on some of these documents? Or is this a key decision element that you need to contextualize with the specific harbor that you want to go into and the drivers that you want to task to do that, right? And this semantic scaffolding, this is really something that needs to be put into rock solid foundation. That's what I try to say. And to find drivers that have these, right, in all the HR documents that pile up in your document management system, that's a perfect, superb task that you have.
So what you're saying, René, is really, and since we wanted to keep this short today, what you're saying is, and explaining a little bit, I don't know if the term neurosymbolic AI has already been explained to the audience yet or not, but what we see with the 5% that really manage to get success out of the AI initiatives, they combine the neural network approach, the probabilistic engine for elegance and user experience, with the deterministic of symbolic AI, so reasoning around across structures that are symbolic and such deterministic, right? So it's about building that scaffolding, symbolic scaffolding, building an architecture around this that gives us the repeatability of high quality decisions, deterministic outcomes as per each of these boxes, let's say, to be able to assemble an elegant and great solution at the end, right? Because I think this looks like a little bit of the role of the technologies. You need the dependability in all of these boxes and their correlation, which can come from symbolic AI, and this is what our clients invest in, right? And then you can use the GPT model to integrate it all into a nice shrink-wrapped, customer-ready product. But it just needs the two sides, really. If we're talking about the 5% that manage well, those are the ones that make the investments on the symbolic side, and then find a way to fuse the two. And just to give a little bit of shout out to your team, this is what eccenca is about, right? Helping companies build the scaffolding for the symbolic part, but also use this like an operating system that also allows companies to fuse the symbolic capabilities with the GPT capabilities to end up building integrated products that are elegant and user-friendly on the one hand, and dependable on the other hand, right? So yeah, I mean, this is just an opener. I mean, we'll have lots more talks that go deeper, but thank you very much for giving us a little bit this Deming side view into what decisions are all about. They're almost like big machines with a lot of moving parts, and we need to make sure they all work well. Thank you very much, René, for coming. We'll have you back soon. We must have you back because there's a lot of explaining that needs to be done. Thank you very much. You all have a great day ahead of you. Thank you for your time, and bye.
Thank you for having me. Bye-bye. Cheers.